So we've basically run or specified all of our water supply and infrastructure, and that gives us enough at this point to go back and optimize and run one of our scenarios. And that's basically done very simply by clicking the Optimize button. This writes out all of the equations that are needed, and those equations include every single time step in our one-year analysis, and does all of our mass balance, find the combination of options that will meet our demand while meeting also the outflow targets that we had specified, and then transfers the data from the solver, reads that back into WMOST, and writes our output file. So once that's done, it basically comes back to the intro tab. You can view the results by clicking on results, and this gives you basically a pre-formatted report that provides at the upper right corner the cost and revenue for that system. So we have here the total annual costs that reflect the cost of the existing system plus the annualized cost of anything else that we've implemented to meet our demand. And revenues are calculated based on demand times our rates, and same with wastewater revenue. So if we go down, we see that the various management practices that are possible in the model are listed. A lot of them are zeros, and that simply means they weren't selected. Some values are close to zero, and they're basically just rounding errors. But on the stormwater BMP, it did select a half-inch infiltration trench as a way to recharge our aquifer and provide the basis for meeting our stream flow targets. This gives us the number of acres on which the stormwater BMPs were implemented. Basically, it implemented on what seems to be pretty much all of the developed areas received some kind of infiltration trench treatment. This is the cost that's calculated for this level of implementation. It did not select a bigger infiltration trench because that turned out not to be cost effective. It did add additional stormwater pumping capacity to the rate of 0.09 MGD, and the cost of this particular option is presented on the right. And that cost includes, I should note that, the cost of the additional capacity plus the cost of operating any existing capacity. So it's the total cost for stormwater pumping. Surface water. The groundwater did not get, there was no additional groundwater pumping capacity added, but we do have a cost. And again, that's because the cost that's presented in the report is the total cost. So existing plus whatever additional capacity, and the column on the left tells you that there was additional capacity added. And then there's our IBT wastewater charge. That's the charge for the wastewater treatment plant that happens to be in a basin that's separate from the one that we're modeling. So there's an export of wastewater from our subbasin to the wastewater treatment plant, and that gets reflected in our IBT. So that's the report that it provides. We have another question. That's the result.
The variability in the amount of acreage for the BMPs, does that come from some sort of price differential between the different soil types or land use types? Where does that come from? with the optimization have chosen, let's say, 5 acres in one site and...
So I heard a question that asked why is there variation in the question acres that on which BMPs were implemented?
Yeah.
So if you have an area where you have an equal number of acres of each types of, each HRU, variability could reflect the relative efficiency of recharge and this BMP. There's differences in the cost of implementing BMPs on different types of land use, and there's also a difference in the effectiveness to achieve to achieve a net recharge. So it would pick the most cost-effective first and basically work its way down. And it could be that on some types of HRUs, it's just not cost-effective, so it won't use it, or it will use it only to the degree that it needs before the next most expensive management option comes in. I mean, in this case, it could also reflect differences in the composition of our watershed, where we've maxed out and reviewed the data to see. I think it's much time.
We actually made up time. So we're
over a lot.
We
have one more question.
This might be going back a bit, and I may have misunderstood something. In terms of demand, there was something mentioned about price signal changing the demand, which I imagine is going to depend on the particular economic model that applies for each municipality. I don't know anything about economic modeling, but it seems like depending on how wealthy the residents are, the price signal would have different consequences, and I'm wondering whether, like, how much, I want to hear more about the economic modeling and whether you need an economist in order to know how to customize this for a particular community.
Did you get that? I did. I'm thinking about how best to answer this question. The values that we've been using come from the literature, and there are likely differences between different types of users. I'm just trying to go back to the... So I think in our example, we did not specify different, we do have different elasticity, for example, for industrial versus residential, commercial, and municipal. But you would want to either use values from the literature that reflects those differences, or you can do studies, and you'd have to work with economists to basically design a study that will evaluate the price elasticity within that particular community.
And there are some references in the user guide for you to look up values from the literature. We do refer you to some sources.
Right, and one of the economists in our group sent a paper a couple of days ago because he was surprised at the minus 0.2, and in that separate study, it was like minus 0.3. So there is literature.